Hey, it's Brent. In this video, we'll cover 9R high flow hydraulics, the connections on the back, suggestions for implement connection, as well as ways to balance and optimize hydraulic flow from the tractor. Let's get started. The first connection we'll talk about is that case drain connection. The case drain is a zero pressure return that we'll use to return oil from the case of the motor for your fans or blowers. It's a very important connection as it protects that motor from overpressurization in the case, motor damage, or seal damage in that motor. That being said, that case drain is one of the first connections you want to make to the tractor, and it's one of the last things that you want to unhook from the tractor, whether you're testing an implement prior to the season or you're hooking that implement up to get ready for the season. The next connections we want to talk about is the Power Beyond. In this example, our Power Beyond couplers are actually present in two spots on the back of the tractor. Later in the video, I'll get into why there's two Power Beyond couplers on the tractor. For now, let's just focus on the Power Beyond and identifying those connections. Looking at the Power Beyond a little closer, we've got a red connector on the left. That's our pressure connector. We've got a black connector over on the right. That's going to be our return connector. Do note that the tractor should not be running when you make these connections or you disconnect the hoses from the tractor. In the middle, you'll find a load sense line. It's important to note that our 9R tractors are pressure flow compensated and they are a closed center system. Keeping that in mind, if this tractor doesn't have an SCV activated, the pump is pumping at a minimum flow rate. So if we have a hydraulic drive air cart or we have an electric power generation planter with planter power gen or anything else hooked to the Power Beyond, unless an SCV is running or a load sense line is connected, the tractor doesn't know that it should be pumping oil, and it could cause problems during calibration or stationary row unit runoffs. So if your implement has a load sense line, we want to make sure that we get it connected. Also note that if you installed your Power Beyond couplers or if you're having issues, during installation there is an orifice or a small screw that must be installed to make sure that load sense builds pressure. Let's take a closer look at our SCV couplers. If we look at our SCV couplers, we have an extend and then we have a retract side. So on the left we've got extend, and over on the right we have retract. It's important that we know that because when we enter the cab of the tractor, depending on which way we move the SCV paddle is going to determine which side of that SCV stack gets pressure. So looking inside of the tractor at those SCV paddles, if we push that paddle forward, that's going to pressurize the retract side of our SCV couplers, or the right-hand side. If we pull back on that SCV paddle, it's going to pressurize the left-hand side, or the extend side of our SCV couplers. So if we're looking at hooking up connections to a planter or an air seeder in regards to the vacuum fan or the blower motor, we want to make sure that we're pressurizing the retract side. So our pressure side of the hose should be on the retract side of the couplers. That way, when we put the fan motor in detent to run, we'll push forward on that SCV paddle. And then when we go to shut down, either for maintenance for the end of the day, we'll float that SCV by pushing it all the way forward and clicking it down. If we were to do it the other way, in order to float the motor, we would actually be back pressuring that motor and we could cause damage to it by doing so. Now let's discuss a little bit more about a high flow 9R tractor and what those connections look like. So looking a little closer at our SCV couplers again, when we have a high flow 9R tractor, we're going to split those couplers across two pumps. So if you think about a final tier 4 9R tractor, that's going to have 115 gallons per minute of flow. But that 115 gallons per minute of flow is not available anywhere on the tractor. It does matter where you hook those connections to. On an interim tier 4 9R tractor, we had 78 gallons per minute. Again, same thing. Our couplers are split up across those two pumps. So if we look at our main pump on a 115 gallon a minute final tier 4 tractor or 78 gallon a minute interim tier 4 9R tractor, we're going to have that 57 gallons or 48 gallon per minute flow on the bottom three SCVs. So SCV 1, 2, and 3, as well as our Power Beyond couplers that are lower. That pump is also going to be responsible for steering and braking. When we hook our connections up and we think about our total flow and total requirements for hydraulics, we want to keep in mind that it's going to take 10 to 15 gallons per minute for the tractor to steer and brake. Then the other pump On a final Tier 4 tractor, an additional 57 gallon a minute pump, or on an interim Tier 4 tractor, additional 30 gallon a minute pump is going to be put on that top set of Power Beyond couplers and any SCVs above number 3. In this case, 4, 5, and 6, plus those top Power Beyond couplers. So when we look at that, we want to keep that in mind as we're making connections to our implement. Let's take a look at an example. On the top right-hand corner of the screen, you'll see the hydraulic requirements for a hydraulic drive air cart. It takes about 10 gallons per minute of flow for the hydraulic downforce while you're seeding through the field. It's going to be on average about 3 gallons per minute per meter to run that hydraulic drive, maximum of 4. Depending on your cart, whether you have a dual fan cart or a single fan cart, your hydraulic flow requirements could be upwards to that 25 to 30 gallons per minute to run that fan if we're at a high speed. 25 gallons a minute to raise the implement, as well as remembering that we need that 10 to 15 gallons per minute to steer and brake. So our first instinct when we hook those hoses up would be to make connections like what I have listed here on the screen. We'd hook our hydraulic drives to that lower Power Beyond, and we'd just go in order. Lift lower on number 1, wing fold on 2, fan on 3. Taking that all into consideration of what our flow could potentially be, that could be over 60 gallons a minute of flow, which would maybe cause our fan to slow down at the end of the field when we raise the implement, or could cause hydraulic issues throughout the field. One of the things that we may also think about doing is hooking our hydraulic drive to that second pump. That would take that 9 to 12 gallons per minute away from our bottom main pump, and it would put it on our second pump. One of the things to remember about doing that is if you move just your hydraulic drive there, ensure you have your load sense hose connected. Without it, that second pump wouldn't know that it needs to be pumping oil and may be in a low flow situation. One of the recommendations that we would make would be that you would move that fan up to that second pump, whether it's a final Tier 4 tractor with that 115 gallons a minute flow or an interim Tier 4 tractor at 78 gallons a minute. This would balance the hydraulic load on the tractor and give you much better performance. And whether you have that hydraulic drive on that second pump or top pump on the final Tier 4 tractor, either way is fine. On our interim Tier 4 78 gallon a minute tractor, we would suggest that that hydraulic drive stays on that main pump. If we have a dual fan cart, we suggest that that bottom chute fan and that top chute fan be split across the 2 pumps. That way we're optimizing our amount of hydraulic flow and preventing the fan from slowing down or from starving oil from another spot on the tractor. So in this case, in this example, we'll put that bottom chute fan on the second pump as it's our primary fan, and that top chute fan would go on our main pump in the event that we'd be running another product through that chute. Let's talk about a planter example. Above on the top right-hand corner there, we've got our planter flow requirements. Not as needy necessarily as an air cart, but certainly something to look at as well. We won't talk into depth as much about these planter flow requirements as much as I'll show you some of the suggestions here on the screen. So we're talking about variable rate drive, planter power generation. We suggest that that would go on the Power Beyond. If it's a hydraulic drive planter, variable rate drive, you will not have a load sense line. If you have an electric drive planter with planter power generation, there will be a load sense line on that planter. We highly suggest that you hook that up so that if you are doing stationary meter runoffs or verifications, that you have the oil flow that's required. Generally, we'll put our lift lower frame on SCV 1, hitch marker on 2, and we'll try to split our vacuum fans across those 2 pumps again. Your tractor as well as your planter configuration may look a little bit different depending on the model. Just make sure you're using the suggestions that we've talked about so far to try to balance the load across both of those pumps. Now that we've covered suggested connections, it can be good to talk about hydraulic flow settings in the cab, as that number correlates to gallons per minute of flow, as well as engine RPM, and helping you understand how much engine RPM is required to get the hydraulic flow you need. For that, we'll reference section 70 of our operator's manual related to selective control valves. We'll see in the operator's manual, we'll find a chart like this one. This chart is going to give us the SCV flow approximate gallons per minute related to the number that we choose in the cab, anywhere from a 1 of 0.5 gallons per minute to a 10 at 35 gallons per minute. Keep in mind that these flows are also related to engine RPM, and a good guide for you to use to set your engine RPM when you're using Efficiency Manager or you're throttling back and shifting up. In that same section, you'll find SCV pump flow, gallons per minute total on the pump based on engine RPM. So you can use this chart to give you an idea of how many RPMs it takes as a minimum for the flow required around the implement. Use this information to help you with those SCV settings as well as your RPMs of the tractor. This is important as we move into our next section here in the video of talking about flow sharing. So be sure that you're optimizing your SCV settings as well as engine RPM, keeping in mind that we only have SCVs in constant flow that need to be in constant flow, and SCVs that can be on a timer or at a time detent are in that setting. Let's talk about flow sharing. Flow sharing is a technology inside of the tractor that's there to help prevent starvation of the pump as well as prevent critical functions of the implement from losing flow. So that being said, SCVs with flow set to constant are a primary function as it relates to flow sharing. Things like vacuum blowers, air cart blowers, things that are in that constant detent can be considered a critical function or a primary function. SCV's flow set to timed detent or a timer are going to be considered a secondary function. So when the tractor looks at those flow settings within the machine, it looks at its total capacity for flow. It's able to make calculations as to how much oil is available, how much flow is available, and if need be, if we get to the end of the field to raise the implement or we have a significant flow change, the SCVs in the tractor are going to respond to protect those critical functions or primary functions. So if we don't have our system balanced very well, we get to the end of the field and we need that 20 gallons a minute to raise the implement. If we don't have enough flow based upon our SCV settings and connections that the tractor can handle that, it will actually slow down or take flow away from our secondary functions. That being said, our implement may raise slowly or we may have issues raising the implement. If for some reason our tractor is set with all of the SCVs in constant and we have no timed or no timer detent positions for SCVs, then it's going to reduce flow on all SCVs at an equal rate. So in that case, not only would your raising and lowering of the implement be slowed, but you may also see a decrease in vacuum blower or air cart fan speed.
Thank you for watching. Connect with us by subscribing to Precision Ag Answers on YouTube and following RDO Equipment Company on social media. Visit rdoequipment.com for more precision ag resources and solutions.